and click the button at the bottom.
Is it on?
No, I'm still seeing you.
Okay. I don't know why.
If the window has to be active, Pat. When you're screen sharing an image in Windows, you've got to actually be on the image. Otherwise, it won't show up. I think that's what I had yesterday.
Is that showing now?
Yes, it is. Yep.
Okay.
And there's Bob.
That's the main screen. All right. So, Bob, we're live right now, buddy. Just so you know.
Okay.
We'll just do a little cone of silence for a second, and then I'll start it up. Just gotta double check a few things. Yeah. All right. I'm gonna put this over now. Oop. That's not what I want. Alright. It should be yes. Bro, I can hear you can hear some breathing going in. Okay, you guys should see us. You go to the home page, you should see everything right. Alright.
Yep, it's showing fine here, Pat. I'm going to mute again. Bye.
Okay, bye. Okay. Bob, I can hear you breathing.
How's this? Better?
Yeah. That's good. Let me see. Have we flicked over yet? I'm still looking.
Minute and a half.
Okay. I gotta tweet out, man. I haven't done this. We might start a little bit late here. It's okay. Let me just do this really quick. .30, isn't that? Okay, I'm just getting this out. All right, guys, you ready to roll?
What time is closest approach exactly?
5 this morning. It's on that document. I think it's 13 minutes past 5.
Okay.
That's universal?
Yep.
All right, guys, we're starting to broadcast live now, so I'll start us up. Hi, everyone. This is Patrick Paolucci with Slooh Space Camera. I'm here today with Bob Berman, longtime Slooh editor, friend, and astronomy magazine columnist, as well as with Slooh engineer Paul Cox. And tonight we have a special show plan for you. We're going to be tracking live the potentially hazardous asteroid 2012 QG42, which is on its close approach today. And we're going to be showing this live from the Canary Islands. Paul Cox, our engineer, is going to be tracking this using our own telescope equipment in the Canary Islands. We have multiple telescopes that are going to be looking at this. For those of you remember, this is the second asteroid that has come in on a close approach to Earth that is not expected. The last one happened in June of this year that we tracked as well. And we're excited to do this as well to show you guys and to educate the public of what's going on out there flying around outer space and some of the dangers that pose to Earth. Now, before we get started, I wanted to mention a couple things regarding Slooh. This is actually our 10th anniversary, believe it or not, coming in December of this year. And Bob, you've been with us for multiple years, as long with Paul as well. And maybe it's kind of fitting that I guess the end of the world is planned for December. That's going to be our official 10-year anniversary of Slooh. So it's kind of funny there. But so Bob, tell us a little bit about this particular asteroid and your thoughts on this. I'm sure this is kind of scaring me a teeny bit, because this is the second unexpected asteroid that's paid a close visit to Earth in the past 60 days. And on top of that, we just had another comet or asteroid slam into Jupiter just a couple days ago, and that was not expected either. So can you tell us what your thoughts are on that while we start this broadcast?
Well, it really is worlds in collision out there. It's, you know, we used to call it space, which suggests there's a lot of room, empty room up there. But we know that there's a lot of other things keeping us company, close company. And sooner or later, we're going to have something with our name on it that comes in. It wasn't that long ago. There are people alive today, not a lot, but there are some people alive today who were alive when the last truly big object came in, blew up in the atmosphere a few miles up, and destroyed everything within 50 miles in all directions. And that was just barely a century ago. So can it happen? Absolutely. Will it happen? Absolutely. It's only a question of when. And these objects should remind us of that.
So, Paul, hopefully you can hear me. We're looking at several feeds now on the Slooh.com homepage. And you guys, that's the best spot to look at this. I will, or Paul will, be screen sharing in every so often images of the asteroid for you, for those who are watching this on YouTube only or on the G+ page of Slooh. But if you go to the Slooh.com homepage, that's SLOOH.com, you can actually control these feeds that we're showing, as well as other graphics that Paul's incorporated in other images. So that's the best spot. In addition to that, you can also access the Slooh conversation box, which can ask questions to Bob, myself, or what have you. And so we recommend you go there for the best presentation. But Paul, perhaps you can quickly give us a review of the channels that you've got us set up on tonight.
Yeah, certainly. I would make the personal recommendation that people don't watch on the YouTube live channel, or don't watch just the Hangout. Watch it on the Slooh homepage, where the Hangout is embedded, so you'll still get to see the Hangout. But if you go to the homepage, it gives you the opportunity of controlling which telescope feed you're going to look at. And we've got 2 live feeds set up tonight. The first one, if you look at our homepage, there's a big circle there, and inside that is the live image. So if we go on the first feed that we've got set up tonight, it's the half-meter telescope. Now, although this is a massive telescope and our best telescope, it's actually not the best instrument to be looking at this object, because if you go to that image on the screen, I'll tell you where the asteroid is. It's a little dashed line at about the 9 o'clock position, off to one side. Now, as color images come in, that little dotted line, it might come up red, green, and blue because we take different images through different color filters. But it will give you a very good view of the asteroid moving across that star field every few minutes. Now, the next feed we've got up is probably the best one that we've got tonight. This is what we call our T2 high mag telescope. So this is really got quite a lot of magnification. It's got quite a small field of view on it. And what we're doing here, the last image we saw, the ½ meter, is tracking the night sky. So that's why the asteroid looks like a streak of light, because it's moving as we take the image. But this one, I've set this up so we're actually tracking the asteroid. So the asteroid that we can see in this image at the moment in the T2 high mag telescope field of view is the dot right in the center. That's what the asteroid looks like. And all of the streak lines in the background are the stars. So that gives you some indication of how quickly this asteroid is actually moving, or its apparent motion against the background stars. We've got a couple of other little graphics set up in there as well. Some of those might take a little bit of time to load. I put a little time lapse in that some of the Slooh members got last week, so you can see the asteroid traveling across the sky in a series of 5 images. That was taken on the 7th of September, because as soon as this asteroid was discovered, Slooh members just jumped on the Slooh telescopes and started taking images of it. There's a couple of finder charts as well if you're interested to know whereabouts in the sky it is. You're not going to be able to see it with your naked eye, but I just thought it might be interesting to just see where it is in the sky, so you know where we're looking tonight. So, and yeah, the last channel I put in there is a little bit of a joke. Really.
You've got the big answer. All right. Yeah, you like that
the future question mark.
There you go. I like that. Hey, Paul was mentioning one thing that I wanted to bring up really quick, and that was about membership. Membership on. If you're on Slooh.com, you just click that membership link. It does support all the free programming that we do. As you can see, we have a lot of shows already counting down. Please consider it. Not only are you supporting the free program that we do on the homepage for the whole world to enjoy, but also you get an opportunity to control our telescopes in the Canary Islands, which is awesome too. And we have as I mentioned before, this is our 10th year anniversary of Slooh, and we've got members from all over the world. Guys who are experts to guys who are just beginning. So, you know, if you want to check out certain objects, including the solar system, all the way to galaxies, nebulas, comets, what have you, you can do that using our system. And I have to tell you, it's very easy to use. So that's great. Please Pat, consider that.
Pat, people do email me after the shows. It's not just guys, of course, it's girls as well. We have got a huge number of female Slooh members out there. So let's not offend them.
Excellent. You got it. You got it. And then also, you guys, just really quick, we're running a special promotion that's focused around our upcoming release of our iPad app. The iPad app is going to be awesome. It's going to give people one-touch command of Slooh robotic telescopes right from an interactive sky chart. If you go to slooh.com/mysky, M-Y-S-K-Y, you can get more information on that, and we've developed a bunch of perks around the release of this particular product, as well as some other perks like sponsoring a classroom, all these different things. But one of the main perks we have tonight is we're actually included a telescope if you get to the certain level. And it gives you unlimited images for a whole year. You get a telescope, and you're going to supporting Slooh. So it's a really important initiative for Slooh. We want to build out our network for obvious reasons, so we can cover more events for the members, and you know, please consider it. Bob, before we get rolling here, I just want to let people know that I am going to be inviting in the founder of Slooh, Mike Paolucci. He's coming in a second. I'm going to put an invite out to him to join our hangout. Bob, you obviously know Mike from all the years you've worked with him in the past. And I invited Mike on to come and talk to more about Slooh in general, about our history, because this is our 10-year anniversary coming up, and I thought it was appropriate for him to join in. I don't think he's been on one of these hangouts since we started doing them, so it's going to be fun to talk to him as well. Hey, Bob, I'm looking on the T2 High Mag. It looks like Paul's got some fascinating shots going there. What do you think about that?
Oh, it's really very exciting. And for people who wonder what this would look like if you could get up close, Pat, this is a piece of an asteroid. I'm going to hold this up for those of you who are on the Hangout or at our homepage and can perhaps see this. This is an asteroid fragment. Now, the difference is the one that's coming by tonight with the catchy name of 2012 QG42, can't forget that, right? A really catchy name, is 14 stories in width instead of just a small size like this, which plummeted into Argentina about 500 years ago. Another thing about asteroids is that almost all of them will pull on a magnet. If you get a little piece of one, here's a powerful magnet, boom. The magnet is going to be attached. They have interesting properties. Many of them contain, obviously, iron or nickel and will attract a magnet. And the problem with these, unfortunately, these PHAs, that is potentially hazardous asteroids, which have clobbered us in the past, will clobber us in the future, is that we know there's probably 4,700 of them. We have tracked now, and we know the orbits of about a quarter of those, and that leaves 3/4 of them that will cross our orbits, that potentially can collide with us. And if they weigh more than 60,000 tons, and the bigger ones certainly do, they come into Earth at full cosmic velocity. This one's traveling 6.9 miles per second. Just think about that. That's 15 times faster than a high-velocity rifle bullet. Usually, our atmosphere will slow them down so that by the time a piece of an asteroid hits the ground, if it makes it all the way to the ground, it's only going about 200 or 250 miles an hour. But the larger ones, they don't get slowed down at all, so they come in at full speed, and that's where the danger lies.
So I'm right in the middle of inviting Mike into this hangout as we get moving on here. So, Bob, I always want to know, because we saw, for those of you that didn't see it, you may have noticed there was a story on an asteroid or a comet running into Jupiter, and the amateur astronomers were able to see it. It was pretty amazing. There was this bright flash, one of the images that the guy had, and it was spectacular. And we actually did a live show on it as well, just talking about it. An object like this, Bob, this, as you said, it's about a 14-story building in size, and it's traveling at close to like 7 miles per second. If this was to hit Earth, do you have any idea of? Do we have a way of knowing of the kind of damage it might do?
The damage is a function of both of its mass and especially its speed, because kinetic energy, how much power something has to create damage, is a function, if you remember your high school physics, of velocity squared times the mass. So change in mass, if you double the mass, you really double the force of impact. But if you double the speed, you multiply the force of impact fourfold. If something's 10 times faster, it'll be 100 times more destructive. So the speed is very, very important. And it's related to mass only because, as I said before, if an object weighs more than 60,000 tons, it will not be slowed up by our atmosphere. So it's going to come in at full cosmic speed. Something coming in at 7 miles a second, which is the closing speed of tonight's asteroid, is tremendously destructive. This is roughly 30,000 miles an hour. Compare that to the speed of just 250 miles an hour for the average meteor impact. 250 miles an hour versus 30,000 miles an hour. You know, you're talking about something that's far more destructive. You have to multiply that by itself squared to see what the difference is, and wow. That's 100 times greater speed means it's 10,000 times more powerful. So it could easily 14 stories across. If that weighed more than 60,000 tons, that would probably be kind of on the edge of meeting that critical mass, but it could destroy a city.
You know, it's interesting, Bob. Are you at all just, you know, just for those of you who are joining, this is Bob Berman, from longtime Slooh editor and Asteroid magazine columnist. And Bob, are you at all concerned about the two back-to-back events that have taken place that we've covered live on Slooh now, are you concerned at all about, is there more activity out there than we're expecting, or is this a normal thing that's going on that we just never hear about?
Yeah, I think we're detecting them more. I think that's part of the thing. It's also a little bit of a coincidence coming into play, and I'm just very happy this isn't happening on December 21st of this year, so that the Armageddon and end of world and Mayan calendar people don't have something to talk about, and they don't say, "See, told you so. Told you it was a dangerous day." So we just hope something like this doesn't happen on that date. But I mean, I think Earth should gather together. You know, just recently at the International Astronomical Union conference, Paul just informed us of this, that there was a decision made to officially recommend that these potentially hazardous asteroids be tracked more thoroughly, more carefully, because our lives might depend on it.
Yeah, absolutely. Well, we had now just joined us is Mike Paolucci, who is the actual founder of Slooh. And Mike, this is back, I guess Slooh actually launched, it was around, I guess, December of 2002, 2003. And Mike, welcome aboard. Thanks for coming on the show tonight. Appreciate it. I'm going to put you on full screen so everyone can see you.
Very nice to be here.
Excellent.
So I don't need headphones for this, I guess, or microphone.
No. Only the professionals need the headphones.
It's truly amateur night.
Yes, exactly. So Mike, did you ever think that here you are 10 years ago from having this idea that people would want to connect to space via robotic telescopes? Tell us your thoughts of why you started Slooh, and maybe you can kind of share, you know, what you think of us now. That look at this, we're doing live imagery, showing tens of thousands, even millions of people at a time, what's going on out in the universe live. What's your thoughts on all this?
Well, it's just awesome that we're still here 10 years later. Bob, it's great to see you.
The same, Mike.
Bob and I collaborated on this well before we launched. My brother and I obviously have been collaborating since I was born. He'd been counting on me as a youth. But 10 years later, the fact that this thing is still going is a testament to people's interest in the night sky. It was always my supposition that space and astronomy is sort of fundamental to human nature. People want to know what's going on. They're curious about the world around them. More and more with light pollution, all over their cities, it's harder to have a connection like maybe even 5,000 years ago. I tend to think the Mayans probably had a closer connection to the night sky than somebody who lives in New York City today. So the fact that we're able to sustain this, and through the membership and through people's participation and support, is just great. And it's nights like tonight when we get massive audiences in here, and we're actually out driving the press, Wired and LA Times and other people to write about this. I feel like we're not just passively watching it all, but we're actually actively getting the world to pay attention, and we're bringing this to their lives, and it's enlightening, it's enriching, it puts the world in perspective. It's nice to take a step back from the day-to-day grind to appreciate just how Peasley we really are in all of this picture, and it's just great to be here celebrating with you guys.
We're glad to have you on. There's you remember Paul Cox, I'm sure.
Coxie, how are you?
Yeah, hi Mike.
Nice to see you. Now, Paul and I go way back as well. Paul has been the most loyal engineer flying all over the world, as all of you probably know, administering this equipment. To this day, Paul and I have not met in person. He lives in England, I live in the Northeast, and it's been a great bond and friendship over our love and loyalty to the sky, and it's good to see you, Paul.
Thanks, Mike.
I think it's
That's
also amazing that we're not only looking at an asteroid that's about 1/20th the distance to the nearest planets as it whizzes by tonight, making its closest approach to Earth. We'll, of course, be talking much more about it. But all of us who are putting this together, Mike is there, if I reading correctly, if this is home in Connecticut. I'm in upstate New York. Pat's in the Los Angeles area. Paul is in Britain. We're all over the world as we watch things that are outside of the world and bring them to you.
Indeed.
Exactly. Actually. So, Mike, when you first started Slooh, did you just feel like it was what was your experience? I believe you told me a story once is because you actually bought a telescope and you suffered through trying to learn how to use it in New York City, and you realized from that day that there's got to be a better way. Isn't that true?
Yeah, absolutely. The natural curiosity is there to want to connect, and then everybody takes the first step, following Galileo's footsteps, and tries to go out and get a telescope. And, gets excited about the fact that you're going to put your eye to the eyepiece and look up, and boy, you're going to see galaxies and supernovae, and the whole thing's going to explode in front of you. And then you kind of realize, there's not any instant gratification in it other than looking at the moon, which is fabulous. But once you've done that, you can't really explore. And, our vision was, how do we remove all those barriers? People don't have time. They just don't have time to mess around. They don't have time to deal with the weather. They don't have time to figure it all out. And, what we wanted to do was just make it as easy as turning it on and putting your eye to the monitor, and up would pop all of this stuff in live, living color. And you could, with a little imagination, be aware that what you were seeing, was happening right now. These weren't just static photos in a database. You're not looking at Saturn when it's not in the night sky. You're actually looking at light from these distant galaxies and thinking to yourself, wow, that took, 30 million light years to get here, and it's just hitting this telescope lens right now. And it's coming to me, and I'm kind of envisioning, the grand time scale of what happened on Earth 37 million light years ago, and, how that all plays into man's, relative position in this. For me, philosophically, it's all about the fact that, we as humans have only in the last, say 100 or so years fully understood the grandeur of what's out there. And I think it's hard for it to kind of seep into the, the collective consciousness of man. We have so much institutional baggage, if you will, that kind of keeps people, with humankind at the center of everything. And, in part, Slooh is an attempt to help everybody look and think and imagine what it really is. And, upon reflection, I think it helps us evolve. So that's where it's coming from.
Right. Well, one of the things, too, I think, is that, over the last 10 years, if you look at it, you've seen stores like Discovery Channel go away. The hobby shops, the specialty retailers, that's where a lot of telescopes were sold. And if you don't really get that handhold sell and understand how to use the equipment, you're really going to probably have a bad experience with telescope. And really, it doesn't benefit Slooh at all to have people turned off to actually looking up to the sky. We want people actually using telescopes, because then it makes them want to get into the hobby and then be a part of the Slooh community and do what we do on a whole different level, which is bring you real-time deep sky images in within a 5-minute time frame. I think the other day I asked Paul, we were looking at the Eagle Nebula, and I asked Paul straight out, what would it take for an amateur to go see the Eagle Nebula right now? And what was it, Paul? Tens of thousands of dollars. and
tens of
hours
thousands of pounds
time.
and hours of patience. And what usually happens is you spend that amount of money. You go out. You can only do it on weekend nights, Friday and Saturday, because you've got to get up the following morning. But what tends to happen is most people don't live at fantastic sites like our Canary Islands Observatory, so it takes you an hour to set your equipment up outside, and by the time you set it up and you're ready, it's cloudy. There are so many telescopes, and expensive telescopes as well, which are stored in boxes. People buy them and they never have the chance or manage to build up the expertise to actually use it. And that's really where we step in. You don't really have to have very much knowledge at all to be able to control our telescopes. And Mike has invested hundreds of thousands of dollars in Slooh's equipment and observatories. So it's giving people access to that. I still think it's wonderful. I've been involved since 2003, and I am still amazed at what we achieve. And I'm also amazed at what Slooh members achieve using the Slooh telescopes. It is utterly astounding. Can I just interject here? Because one important thing with this asteroid that we're looking at now, it was discovered by the Catalina Sky Survey on the 26th of August. Within days, Slooh members, and the main guy was Norm Pritchett. He controlled the Slooh half-meter telescope and the one that we're looking at tonight, and he helped to determine the orbit of this thing after its initial discovery. So he took images with the Slooh telescopes, he submitted those formally to the Minor Planet Center, and that helped the Minor Planet Center work out and calculate the orbit that this asteroid was going to take. That is astonishing to me, because Norm's in California, 6,000 miles away from the telescopes he was using in the Canary Islands. It still astonishes me what we do.
Yeah, it's a great global community, isn't it? And we're all over the place, and all of our members are all over the place. And this is certainly an international language everybody can read and appreciate. And that's certainly at the heart of how Slooh came about as well. Just the notion of bringing people together to do something, that they can do together. There's not much arguing about what's out there. We can debate it, I guess. Maybe we can't argue it, but we can all appreciate it.
Yeah.
So if you just joined us, we're here today with Slooh editor and longtime Slooh friend and Astronomy Magazine columnist Bob Berman. He's on the left side of the screen. In the middle there, next to him, is Slooh founder Mike Paolucci. Next to him in that black box behind the scenes is Slooh engineer Paul Cox, and right here on the far right is myself, Patrick Paolucci, with Slooh as well. So we're here looking live at this asteroid 2012 QG42 that was just discovered on August 26th, and this again is the second object that's come into our solar system unexpectedly that we're tracking in the last 60 days. Bob was just talking earlier about the damage that this could do if it hit us. And Bob, I was actually looking at some of the JPL sites and other sites. They have some stuff here that doesn't look like it's that far off. Like have you heard of, Paul, you might know this. Am I pronouncing this asteroid Apophis? Is that how you pronounce that one? You guys know?
Apophis, yes.
Apophis.
Apophis is the most scary one. And let me just quickly correct you slightly. It's always been in the solar system, this object. It did not come in from interstellar space. But,
it did, okay.
And I know what you mean is it's coming into the Earth's vicinity here in the solar system. Apophis is the one that's scaring people the most, because it's going to be passing quite close to us, closer than our TV satellites in the late 2020s, and then it's going to pass by again 6 years later. And there's a small chance, 1.25 million, that it could actually impact us at that point in the mid-2030s.
Yeah, I mean, Bob, that doesn't seem that far away.
Yes, that's when the Mayan calendar should have ended.
I mean, it's only 20, 30 years from now. What should we be doing about this? Because it sounds like no one ever talks about this thing. It's only 20 years away.
Well, that's because on the initial impact, I believe it's April 13th of 2029, if I remember correctly. And on that date, and by the way, that's a Friday the 13th, it's going to skim so close to Earth that its orbit will be changed. Now, there's no chance of it hitting us then. But with its orbit change, when it next comes by 6 years later, also on April 13th, 6 years later, there is a small chance, now 1 in 250,000, I wouldn't worry about that, but it's not zero.
Right. I mean, I was looking at a bunch of other ones. There's Asteroid 2011 AG, is it AG5, I think it is, or if I'm looking at my notes here. That one they say could intercept Earth in 28 years from now, potentially. And then there's Asteroid 2004 VD17. They think they could hit Earth on May 4th of 2102. So there seems like there's quite a bit in the queue here lined up for taking each their own cracks at the planet Earth. I mean, have you? Is the science community? Has there been any warning or people? Because I never really read about this. I don't really see it, at least in the mass media, at all about potential impacts. Are we just not looking far enough ahead to care?
No. We've always known, because all we have to do is look in the past. Now, remember, again, on the last day of June in 1908, that's not long ago. A huge object came in and exploded about 5 miles up. Just flattened every tree for 50 miles in every direction, and fortunately this was a place with low property values. We're talking about south central Siberia, but if that same one came in today, it could kill 20 or 30 million people if it hit in the right place. That was just 1 century ago. Every night, people can see asteroids and bits of comets come in, because every time you see a shooting star, a meteor, that's a piece of an asteroid or a comet that's hitting us, that's hitting the atmosphere. 6 an hour, every single hour of every night. So these things are common, not rare. What's rare are the really large ones, and we've all learned in school now about the dinosaur ending impact 65 million years ago. We even found the crater there, the Chicxulub crater off the Yucatan coast.
Right.
251 million years ago, the great Permian dying. Well, that was horrible. That almost erased all life on Earth, like a car wash, washing dust away. That was a very serious one. So when you think about the rarer events that can destroy half of all the genera on Earth, and then the more common events like the one a century ago that can destroy a city or two, and then there are the more common events like the ones we see every night hitting our atmosphere, and our atmosphere fortunately burns them up, and a few make it to the ground, like the one I was holding up here. A bunch of these fell in Argentina 500 years ago. And so it's happening all the time. What we're monitoring now, Pat, and what you were talking about, is the ones that we can actually see that are perhaps 100 or several hundred meters across, that can really do damage, that can come in at high speed, and hopefully we'll learn to monitor them so they don't take us by surprise. And I know what Pat was just talking about is that the asteroids that have just come in now, we didn't know they existed. That's the scary thing. We didn't know this existed until less than 3 weeks ago, and here it is whooshing by us, 1/20th the distance to the nearest planets, or at least to the planet Mars. And what if that had a bullseye on Earth? There'd be nothing we could do about it.
Yeah, just really quick, if you go on the Slooh.com homepage, and that's where the main presentation is for you people who have just joined us, you can see the orbit in box number 2 of this asteroid in relation to Earth, and right below the panel that you're watching with Bob, I, and Mike, and Paul. So check that out. It'll give you a sense of how close, because this thing really, actually, it looks like it could have struck us. Just looking at that diagram didn't give me much confidence. So Mike, before you got to go, any last thoughts on Slooh, and what are you thinking? You know, this iPad thing that we're working on right now, that we're going to be releasing in the fall or early winter, is I think it's going to be another step for Slooh, because it's going to really give people a chance, I think, to go to take Slooh to another level of easiness to command a robotic scope. You're going to be able, in the iPad app, one-touch command scopes in the sky chart. And I just wanted to get your thoughts of where you think Slooh, what are your thoughts on Slooh going forward?
I'm really excited about the app because I feel like, number one, it's going to appeal to more people. It's easy to spend 99 cents, make a reservation, take control of the telescope, do it once a month, a couple of times a year, and really still have that connection, even if you're not the diehard fan who is going to be a member and really use Slooh every day like our core audience. And I just think going out in the backyard, instead of having your telescope, you're sitting with your app on your lawn chair, looking up at the sky, seeing something with a naked eye, pointing the Slooh telescope to that thing, and then watch it live. Wow, I think that's going to help bring the romance of Slooh, to people and just make it easier to appreciate. Going forward, it's all about, we've reached this place 10 years later. We're pretty stable and sustainable. We've got, several telescopes. Things go slowly because, obviously we're not, Google. We're not releasing an iPhone 5, but we have, enough resource to kind of keep going with, with things as they are. We always welcome people supporting it because we want to build stuff faster, bigger telescopes, get more hosts and more guests and more people to come and participate. So we really appreciate your support. And I just finally like to wrap up just as a nod on the 11th anniversary of 9/11, just to remind people that, Slooh kind of came out of the ashes of 9/11. I was living in New York. My dear friend Blake Wallens died that day, and a year later we got Slooh up and out as sort of a gesture of goodwill toward mankind, trying to sort of bring people together, trying to fight some of the fundamentalist ideas that seem to have, at least at that time, had been winning the day in the debate. And, in our own small way, I feel like Slooh is a positive contribution to that debate. We get people thinking bigger and better. And, here's to you, Blake.
Yeah.
Awesome. All right, Mike. Well, thanks for coming on. We appreciate it.
Thank you, guys.
Come on more often. We'd enjoy it.
Nice to see you. Take care.
All right.
Cheers, Mike.
Bye, Mike.
All right, that was Mike Paolucci, founder of Slooh. It was great for him to come on and talk more about his thoughts on Slooh and how he started it and where we're going with it. You guys, as he mentioned before, membership is hugely important to Slooh. It pays for all the free programming. If you're on the Slooh.com homepage, you can see that. We have shows counting down almost every night now. Paul and I are doing a lot of shows in celebration of our iPad app that's coming out later this year. And we're doing it in a special campaign called M.P.E.C. You can get to it by just going to slooh.com/M.P.E.C, or you may see a banner pop up once in a while. And if you go there, there's a bunch of special perks. These perks are all around Slooh membership. This is a legit company. We've been around, but we're offering special packages for people to get involved with the iPad app now, and that includes also sponsoring a local classroom. I mean, what great gift would it be to give a local classroom of kids 8 to 12 potentially books and 200 minutes on telescopes they could go home and watch and control through their home computer or at the school library. There's a lot of neat stuff that we've got offered there. These are packages that'll go away because we don't offer this stuff normally. Our normal membership package is a subscription-based package, as you can see off the homepage by clicking that membership link. If you want to do that, great. We'd love to have you, but also consider the perk area of slooh.com/MySky. So, Paul, I'm looking at your screen share right now. You've got what we call our T2 high mag telescope pointed on that, and that dot you're seeing is the actual asteroid traveling at approximately 7 miles per second So, Paul, how hard is it for you to track that? Because that seems like it's going pretty fast. Are you sitting there holding the telescope and whizzing it? What are you doing over there?
Absolutely. I'm nudging it. I'm nudging it every 10 seconds. I am having to control it manually. I'm having to control our equipment, the T2 high mag, manually to be able to do this tonight. But the half-meter telescope is actually operating. I set those missions up just as any Slooh member would, but that's not tracking the stars. It's difficult, Pat. You know, this equipment, we don't have anybody on site. It's fully robotic. We don't have support on site. And I have to set it up so that it can go months on end without any manual intervention. And pointing to our T2 high mag telescope runs at what's called f11, and that means it's got a really, really tiny field of view. It's fantastic for planets. It's the ones that we use for Jupiter and Saturn and Mars and stuff like that. But it also means that pointing, anybody who's owned a telescope knows it's incredibly difficult to point a telescope in the first place, even manually, let alone setting it up so that it can be done night after night to hundreds of objects. And you know, it doesn't always get objects bang in the center, but it's always within the image. So it's pretty damn difficult. There's a few little black arts in there that we have to put out. But what's lovely about it is that you know that the time spent setting it up properly is suddenly multiply the benefits of that, just multiplied by the thousands of members who can get to control it.
Right.
So yeah, difficult, I think, is the answer, Pat. Difficult.
So what I'm going to do, Paul, that's I'm always amazed. You know, we've captured this now. This is our third or fourth event like this, and you've hit them all out of the park. You and actually Matt Francis as well. So I applaud your efforts. I know that's not easy because people got to remember you're in the UK, and for you guys who don't know what that is, that's Britain. Just joking, but and the telescopes are actually in the Canary Islands, which is off the coast of Africa. So that's what is that a couple thousand, 1,000 miles away, or 1,500 miles, or like
3,000 miles away from me. Yeah,
3,000 from you. So imagine that. So that's Paul's doing this all remotely, and that's it's pretty impressive. Just really quick, if you're on the homepage of Slooh.com, I'm going to start looking at the chat box on their Slooh conversations to answer any of your questions. So Bob and I will do our best, or Paul, of course. Also, we have other features there. You can pin photos if you are a Pinterest user. Go ahead and pin any of these photos that are coming up in the live shots. Share them with your friends, or follow us. Twitter feed us, or Twitter feed us. You can follow Twitter. You can follow us on Twitter. That's what I'm trying to say. And like us and all those great things. G+ us. Those things allow us to communicate to you about future shows. But you can always come to Slooh.com if you'd like to just see when the next show is counting down.
Okay, and at that point, I'd like to recap for the people who are just tuning in. What you're seeing now are the live images of the asteroid that is going to speed past Earth. It'll be at its closest point to us at 1:13 Eastern Time. You can figure out what that means for your own time zone. And what the Slooh telescopes are doing live is tracking the asteroid in a number of different ways. This is an asteroid as large as a 14-story building. It has already come only 1/20th the distance to the nearest planets. It's close by cosmic standards. And by using the different Slooh telescopes now, clicking on that blue triangle above, you can see the asteroid itself. We're actually imaging this, even though it's as faint as the poor, demoted exoplanet Pluto, which is sort of the paradigm of faintness. We're talking about something that's at 14th magnitude. That's about 10,000 times fainter than the dimmest object you're going to see in the night sky. So this is really, really dim, and nonetheless, there it is, clear as a bell, as Slooh is tracking it realistically. The danger of it? Well, back in my days with Discover magazine, Pat, you probably don't even know this, I was with Discover magazine for 14 years. And we once did a story in Discover that you're 6 times more likely to die of an asteroid impact than you are to die in an airplane crash. So
what is that stat?
That's comforting.
Each of us is 6 times more likely to die from one of these objects hitting Earth than you are to die in an airline crash.
Wow. That's crazy, man. What, Bob, you're throwing out these stats. Maybe Bob or Paul, maybe you could tell us the difference, because I was getting confused myself, being the amateur among you guys for sure. What's the main difference between a potentially hazardous asteroid, a PHA, and a near-Earth asteroid? Can you guys fill us in, one of you guys?
Near-Earth asteroid isn't really a term. It's really near-Earth object. And near-Earth objects are comets or asteroids. But then you get the class of PHA, which is a potentially hazardous asteroid, and Bob can tell us that when I get the next image up. He says, getting out of that one quickly.
So it's a subclass, more dangerous, and someday they'll perhaps have a further subset called the "We're Screwed" asteroid. We thought for a while that the WSA, and though we thought that Apophis was going to qualify. Here's something you should know. When an asteroid is first discovered, this one, of course, was found less than 3 weeks ago, often its crude first orbital elements show that it might impact us. And it makes the headlines and everybody gets really worried. But as greater refinements come into play, we always find that it's going to miss us by more and more and more. And the reason for that is there's only one way for a potential impact to actually become an actual impact, because these things are like bullets hitting bullets. Earth going around the sun at 18.5 miles per second. We move some 36 times faster than a bullet. This is moving 15 times faster than a bullet. So it's not just a bullet hitting a bullet in space, it's a super bullet trying to hit another super fast bullet. So the chances are that if we first see an orbit that yields the chances of a collision, and then we later do an orbital refinement, the refinement would have to be precisely in one direction only. You know what I'm saying here, I know, Paul, that the refinement has to go in only one specific way to make it then actually hit us, but it could go in any of 5,000 other directions, faster, slower, up, down, north, south, to make it miss us. And that's why you may have noticed, the listeners and the viewers tonight, as we see this asteroid approaching us, and it's going to whiz past in just a few hours, that at first we always think the chances of collision are greater, and then as we observe it more and refine the orbital elements, invariably we find it less and less and less likely that it's going to hit us. So remember that for next time if you really get scared by a potential impact. Apophis at first seemed to have a fairly large chance, perhaps 1 in 30, of impacting us. Now it's down to 1 in 250,000.
Bob, what changed that, though? What was the main factor of where it became less risky for us?
Simply finding more details about the actual orbit lets us narrow down the path more, and every time you narrow down the path, it'll almost always take it further away from us than toward us.
Wow. So, Paul, can you still hear us out there? Or are you busy with the telescope right now?
Yeah. No, I'm here.
So what do you got going? Because I know you sometimes been flicking back the T1 high mag, or excuse me, the T1 telescope you've got going. You probably do you have to point that one out a little bit more for us because of the difficulty of seeing that one, or because it's such a wide field, or what?
Yeah, the half-meter telescope is absolutely fantastic for imaging things called deep sky objects, because it's like an enormous light bucket that just soaks up the photons and manages to image these really, really faint objects. But it also has an incredibly large field of view. It's got a pretty nice camera on the back of it that helps give that. So what we're looking at, if anybody's looking at the half-meter telescope view on the home page, you'll see the asteroid, and it's at the 9 o'clock position, and it's a short line. It's probably, on most monitors, maybe 1/4 of an inch long. But from one image to the next, if you keep watching that, or if you've got a Pinterest account, you can actually grab hold of these images for yourself and look at them after. You'll actually see it moving across the field of stars in the background. Whereas the T2 high mag telescope that we've got has got a tiny field of view, so we're really zoomed in quite tight. And because I'm operating this one manually, I'm tracking at the rate that the asteroid is moving against the background stars. So that's why we're seeing the asteroid as the pinpoint, the round dot, with the stars in the background streaking behind. And as you say, this thing, it's got a relative velocity of 7 miles per second. So its relative speed actually changes the closer it gets to Earth. So Bob can maybe explain why that is, but I think it might be obvious to quite a few people. But the closer it gets to Earth, the faster it looks as if it's actually traveling. It's not actually traveling any faster, but it's just its apparent motion on the stars behind. It is.
Well, sure.
So that's what we're looking at with the T2.
And that's as simple as an object close to us just appears to move faster. A car going down the road in front of your house covers a greater angular distance, a greater speed than a plane in the sky, even though the plane takes a while to cross the sky and the car takes only a few seconds to cross your field of view. The closer an object is, the faster it seems to be moving. So it's actually as simple as that in this case. This is a very close object, so it appears to quickly traverse the sky.
So
actually, what was interesting, Pat, you mentioned.
Ahead.
So you mentioned a couple of months ago we covered 2012 LZ1, which was an asteroid that actually came a lot closer than this one. And what I'm doing here tonight, I can actually set up our telescope to track the object automatically, and it has a virtually constant rate of speed as far as the telescope mount is concerned. But LZ1 was so close to us that we actually, to track that, we had to treat it like a satellite, a man-made satellite, because it did change over the course of a few hours. Its relative speed changed so much that we had to kind of keep speeding the telescope mount up and then slowing it down, to actually, the rate wasn't constant, in other words, whereas the rate with this one, to all intents and purposes, is constant as far as the telescope's concerned.
And then there too, there's an obvious reason for it. If an object's truly close to us, then it's a matter of our geometry and the object's geometry, and after it passes the closest point, for example, we may be approaching it while it's approaching us. After the closest point, we're pulling away. There's all sorts of things that are going to change the closing speed and the apparent speed of the object relative to us. The farther away it is, the less that becomes important. But remember, Ole Romer discovered in the 17th century the speed of light by noticing the changing speed of us versus Jupiter. And Jupiter is quite far away. He noticed that there was an actual change in the motion of the satellites going around Jupiter relative to us going toward it or away from it at different times of the year. So these can have profound and practical consequences, watching these objects change their speed. But for people who are just tuning in, I know a lot of people are thinking, hey, this asteroid just missed us. How dangerous is it? We talked about that now a full hour ago. And how do we know that this is going to miss us for sure? Well, we're going to watch it here at Slooh. We're actually observing it just so for people. And there are some people who think the government may be lying to them, that this really is going to hit us. And how do we know the truth? Well, Slooh always tells you the truth. Here at Slooh.
That's right, Bob. That's right.
and actually, on that one, if you don't trust us, you control the telescope. So you're choosing where you point it. So if you think this magical planet is going to come and hit us on the 21st of December, join Slooh, control the telescope, point the telescope to where you think Planet X or Nibiru is actually coming from, and you'll see there's no way that we or anybody else can intercept those images. They're in real time.
Yes, you'll see that until you're destroyed, that is.
Absolutely.
That's right.
If an object gets larger and larger in each image, then I think you need to put a hat on.
Yeah.
As I always say on that event, when you guys talk about that particular event, you got nothing to lose. Then you should just become a Slooh member, and then don't worry about don't have to worry about it. So
well, that's why I went back into my cave, Pat, because all this talk is getting me a little bit nervous, and you might have noticed that I'm back here in my shelter in my cave below the ground.
Yeah, Bob is in his bomb shelter again. He's worried. That's what we call that when he goes dark. The dark background that's his bunker or bomb shelter.
There's actually there's a technical term for that here that's going on here, and it's called night. Night has fallen.
Ah, there you go.
At Slooh, we like to use the right astronomical technology and technological terms for things.
Hey Pat, there is a very serious side to all of this, and somebody actually, I put an informational video up on YouTube about this asteroid passing, and it had no scare tactics in there. It said exactly where it was. It said there's no risk of it hitting on this approach, and the guy said stop your scaremongering. Well, first of all, I wasn't, but secondly, although there is no possibility of this thing hitting us, there is a serious side of this, and this has been recognized just in the last couple of weeks. We spoke about it very quickly at the beginning by the International Astronomical Union. They had their big congress in Beijing, and I think you've got one of the resolutions that they passed there, haven't you? It would be interesting for you, I think, just to read out maybe just the first paragraph of that, if you've got that handy.
Yeah, no, I do. I actually printed it out, and if you want, I didn't know if this was a secret document that you possessed somehow, but I didn't want to mention it too closely.
A very good friend gave it to me, so I'll take the flak for it.
Okay, International Astronomical Union, recognizing that there is now ample evidence that a probability of a catastrophic impacts of near-Earth objects, NEOs, onto the Earth, potentially highly destructive of life and for humankind in particular, is not negligible, and that appropriate actions are being developed to avoid such catastrophes. Let's see. That for the largest NEOs, thanks to the efforts of the astronomical community and of several space agencies, the cataloging of potentially hazardous ones, the monitoring of their impact possibilities, and the analysis of technological feasible mitigations is reaching a satisfactory level. That even the impact of small to moderate-sized objects may represent a great threat to our civilization and to the international community. That our knowledge of number, size, and orbital behavior of smaller objects is still very limited, thus not allowing any reasonable anticipation of the likelihood of future impacts. So
there it is. That's the world's astronomers, and they're not being sensationalists.
It's an independent body. It's the International Astronomy Union has loads of member bodies to it. A huge number of those are academic, and I don't think in the academic world, academics don't particularly like being pushed around by governments to be told what they can and can't say, as much as governments like to think that they can. But it really goes down to all of these conspiracy theories. Frankly, there are so many people with the knowledge. Who could, realistically, if a Slooh member points the half-meter telescope to an area of the sky tomorrow night and they image an object which later observations show up it's going to hit the Earth, and that guy puts it out, say Norm puts it out on our Facebook group, on our Google Plus stream, on all of his social networks, how on earth is that kind of knowledge ever going to be hidden? We've seen it in the Middle East, and China, where the walls have come down, the internet walls have come down, but the news has always got out. It's impossible, I believe, in this day and age to actually make this kind of stuff secret.
Right. You guys, really quick, Paul and others, if you're just joining us, we're here live looking at Asteroid QG42 on its close approach to Earth. You can see it if you're on like T2 High Mag on the homepage of slooh.com, you'll see that dot in the star trails that Paul is tracking right now. And we've been tracking this now for about an hour, it looks like, and we're going to continually tracking it for another hour or two, Paul, although our panel here is going to get off in about a half hour. That you can still watch it live if you like. And in addition to that, I just want to say that this is Slooh's 10-year anniversary. If you're just joining us, and we have a robust membership group, please consider it. It's a great thing to be a part of. Not only do you get an opportunity to control high-powered observatories around the world, you get to interact with members worldwide, and it's for all levels. So please take a look at it. It does support the free programming that we do. And as you can see, if you're on the Slooh.com homepage, we have a lot of shows planned, including a comet one. It looks like tomorrow Paul is going to be doing one.
Yeah, I've got a
as
special
well
one
as
tomorrow.
yeah, and you've got an asteroid recap later tonight. So we've got a lot of shows that we're doing through October 10th in celebration of our anniversary, but also in celebration of the upcoming release of our iPad app. And we think that thing is going to be awesome. It's going to give people one-touch command of robotic scopes right from their iPad app on an in-app purchase basis, which is something we've never done. And if you go to slooh.com/mysky, you can learn more about it, or you can even Google Wired Slooh My Sky. Wired Magazine did a little article about it, and it really will kind of show you what we're up to. But we also developed some perks, including a telescope perk that's included as one of them. You know, we've got classroom sponsorship stuff, free T-shirt stuff. You know, just to be a part of the program, we really would appreciate it. Helps us a ton, and to also, you know, we have ambitious plans, and Paul can attest to grow the observatory network, which would allow us to do more shows through different parts of the day from all over the world. And anyone who's done astronomy knows the challenges. You know, we've been pretty lucky lately because the weather's been really good in the Canary Islands, but, you know, if a storm front comes in and all that, you know, we can't do much. So it really would help us to continually expand our observatory network. Bob, I had a quick question for you. You know, you mentioned, you know, you corrected me on that this asteroid really is in our solar system. I just was curious to know why we can't track. Is it just so difficult to see stuff in our own solar system coming in, or, you know, what can you tell us about that as far as the difficulty of tracking the stuff that's already in our solar system?
Right. Well, that's because of the small size. Most asteroids are within the asteroid belt, Pat, and that's between Mars and Jupiter. Collisions between asteroids and others, and also the gravity, the tremendous gravity of Jupiter, sometimes flings these objects into much more eccentric or oval orbits and sends them out of their well-behaved band between Mars and Jupiter and sends them into new orbits. And enough have done that, so there are a substantial number, thousands, that now go sunward, go around the sun, and intersect our orbit in space. Much more recent information shows that these are mostly inclined in the same flat plane as the rest of the solar system, which makes the collision threat even higher. Now, beyond Jupiter and Saturn, you get to fewer and fewer of these. Beyond the orbit of Neptune, there's a whole other class of objects in the Kuiper belt. These are mostly icy, not rocky. Asteroids tend to be metallic or rocky. The beyond Neptune, we get to the icy bodies, also thousands of them out there that inhabit that. But none of these come from between the stars. These are all bound to the sun. They're part of the sun's original family. And we think the asteroids all formed from a planet that never could quite form because of Jupiter's proximity. The gravity was just too strong, and so it remained thousands of pieces of just rocky debris. The largest of them are only about 800 miles across. There was the Big Four for many years: Ceres, Pallas, Juno, and Vesta. Vesta being the brightest. Vesta sometimes reaches naked eye visibility, where if you're really out in country skies or near our observatory in the Canary Islands, you'd see it as a very, very faint object, about the same brightness as Uranus. But other than that, asteroids cannot be seen. And when we're talking about these asteroids, they are not the Big Four. They are fragments from previous asteroid collisions. I previously held up a piece. I'll hold it up again. And this was one that landed in Argentina. Here's another asteroid fragment. Here's one that landed in South America about 150 years ago. This is the one I had on the David Letterman show, when I was on the David Letterman show. he took this in his hand. He said, "Whoa, you know, I mean, am I in danger here? Is there one like that has my name on it that's going to come in and clobber me?" And the answer is the same as what we're discussing tonight, and that it's not a question of if, it's a question of when. But that when might not be for thousands of years. But to be on the safe side, I'm glad the IAU has now officially recommended that we spend more time tracking them so that we can see them coming. Well, we want to remind our viewers tonight that this one was only discovered 2.5 weeks ago, and then here it is zooming right past us, and it's the second one to come in a matter of weeks. So whoa, we're kind of ducking here and there.
And so in the meantime, at the weekend, we had the surprising discovery that an asteroid or comet impacted Jupiter. So we once again, all the Slooh members, they pointed the Slooh telescope straight to Jupiter to see if there were any signs of that. So it's not just us. By the way, guys, I've had an email from my very good friend who's let me know potentially Earth asteroid. The criteria for it is it has to be larger than 100 meters, and it has to be coming closer than 0.05 astronomical units to be classified as a potentially hazardous asteroid like this one.
And for definition, for those who don't know, 1 astronomical unit is the Sun-Earth distance, about 93 million miles. So we're talking about 0.05. Well, 0.1 would be about 9 million. This would be 900,000 times. All right, so what we're getting there is only a small fraction. It's got to pass a small fraction of the distance to the nearest planets and be 100 meters, or about 330 feet wide. This one seems to qualify. So here's as a potentially hazardous asteroid.
So what, Bob, really quick, is Jupiter protecting us? Is the pole of Jupiter protecting Earth at all, or
well, many say so. Because of Jupiter's huge mass, it weighs the same as 318 Earths. It will attract objects that might otherwise have come in our direction. But before we give it too much credit, Jupiter also flings other asteroids out into new orbits, and has flung a number out in our direction that wouldn't have come here in the first place were it not for its gravity. So probably on balance, it does us more good than harm.
Right, right. Well, if you guys, really quick, if you're on Slooh.com and you want to ask Bob a question, or Paul, or myself, please enter it in there, and we'll try to get to it. We've got about 15 minutes left in this show with the panel. Paul is going to continually image this up until 5:30 Pacific time, 8:30 Eastern time, and that's 00:30 UTC. I believe. And then Paul's going to come back, do a post-recap show for you that are still up. I'm sure, Paul, it's going to be pretty late for you, I know, but in the U.S. it won't be too bad. And he'll be coming on into the Hangout. Are you pulling live feed still, or are you going to be just doing recap stuff?
I'm actually going to be continuing to image this all night. It's actually imaging for Slooh members on the half-meter telescope, so even when we go off air now, they're going to be able to still watch the images in the normal MI that they use. I have also, by the way, for Slooh members, I've made these all what we call FITS missions. So any pictures that Slooh members snap, they'll also get the FITS data for that as well. But yeah, so I'm going to come back on at 0200 UTC, and we're just going to have a bit of a recap on what this thing's done, where it's gone, and have a look at some of the images.
And Paul, your wife hasn't left you yet?
No, she's. I was about to say she's upstairs in bed, but she's probably not asleep, I'm afraid.
So Bob, there's some interesting stuff coming in the chat. What would the government do, you think, if there was an asteroid rolling into town that was, going to hit Earth? Now that amateurs could probably figure it out, I mean, what would you think they would do?
In other words, would they lie or would they not lie? You know, well, the standard science fiction movie thing is that the government lies and says there's nothing to worry about. But these same movies seem to show that when the people find out, and the public always does seem to find out, they run through the streets knowing the world is about to end. They run back and forth. You see crowds running through the streets. I always wondered where they think they're going. I mean, it would seem no place would be any safer than any other place if the world was going to be destroyed. And we've learned what people do when they discover like an amazing event or a potentially dangerous event. And that is what people actually do is they pick up the phone and want to be the first one to tell their friends. So what would actually happen is a lot of phone calls. I'd also like to point out, for those of you who think you found a piece of an asteroid, because make no mistake about it, any meteorite that you think you found is an asteroid. A few have come from Mars, and a few have come from the Moon, and a few have even come from the asteroid Vesta, but almost every meteorite is an asteroid fragment. So if you pick up a rock, I hear this all the time, this is why I'm bringing this up, how do you know whether it's an asteroid or just a harmless chunk of driveway rock? And the best way you can tell is, number one, an actual piece of an asteroid will almost always pull on a magnet. Here's a magnet, here's an asteroid, and look at that. We'll pull on a magnet. Secondly, a real asteroid will have little indentations in the rock. They're called regmaglyphs, or thumbprints, and they're called thumbprints because they look like if it had been made of clay and you stuck your thumb in, you could make little dimples in the rock. Earthly rocks almost never have these, and actual, genuine asteroidal meteorites almost all do have them. So look for these thumbprints in the rock, and also they're usually very black from a fusion crust. Those are the signs that you may have discovered it, but it's not likely. In New York State, for example, just to list one state, only 11 genuine meteorites have been found in the history of the entire state. So that gives you an idea of how rare they are. But it also illustrates that they do really crash into Earth. And we could talk perhaps some other time about people and houses that have been hit with pieces of asteroids. We could do this tonight if you wish.
There you go, Bob. Well, anyway, guys, so here we are. We're in the last part of our show here. We got about 10 minutes left. If you guys have got any questions, I will monitor the chat for Bob. But also, before we get off, I do want to stress the importance of considering membership on Slooh. It does fund all the free programming we do, so please consider it. You also get the opportunity to control telescopes, image the sky on your own, as well as work with a worldwide membership base that coordinates and works together, and it's for all levels, entry level all the way up to advanced. We do have a FITS program now on our half-meter scope, which is working great, and we'll probably be expanding that program soon. In addition, we have our iPad app coming out and a special campaign at slooh.com/mysky, and there's a bunch of unique perks available that are all around Slooh membership, but also in support of the actual app itself. It's a really cool app, and we're looking forward to getting that out because I think it's going to give people another unique opportunity to image the sky, but using only their own pics, which is kind of what we're all about. So,
did you say you had a special perk on the MySky campaign for today?
Yeah, we do actually. We launched it. It's a telescope perk. If you guys go there to slooh.com/mysky, we're actually giving out free telescopes with this perk, as well as an unlimited imaging for a whole year, which is tied right to the iPad app that's coming out. So again, these perks are not going to be around for much longer, especially if they sell out. But once the campaign ends, those offers are gone. So please take a look at them. You know, I also think the cool one is sponsoring the school classroom. I think that's another one that you guys should look at.
Yeah, that's really cool. It gives basically that perk. I mean, this is supporting our campaign, so they are perks. You're not kind of buying something, but I think they provide great value. But those school perks, those school classrooms, sponsoring a classroom, gives a whole class or several classes the opportunity of using the Slooh telescopes live. And I did show on one of the shows I did the other night a very quick walkthrough of how normal members use Slooh, and I think hopefully I showed that it's as simple to use so kids could use it, but also for the advanced amateur as well, especially with the FITS program. But Pat, the telescope deal, is that the same telescope that we did before? Because we've got some information on that if people want to see that.
It's the same scope. It's the exact same scope we offered in some other previous shows earlier,
cool.
I guess for the transit of Venus. So you could go to our YouTube channel and see Paul demoing it. It's a good scope. Paul's used it. He actually took images right out of it with a CCD camera, I believe. So
it was with a webcam, Pat, and we mustn't oversell telescopes because we at Slooh, we know, the limitations of telescopes, and I think what I put down in that video is I'm very clear about the limitations of that telescope and any telescope. It is fantastic fun to stick in the back garden for a couple of minutes and looking at the moon. You'll see Jupiter, you'll see Jupiter's moons, you'll see the rings of Saturn, but you're not going to see galaxies or nebulae with it. But that's the whole beauty of that particular promotion. You've got this great fun little scope that you can use actually during the daytime as well. But so you can see the moon and the planets, so it's great for the kids. But then to see the galaxies and nebulae, part of that deal is that you're going to be able to control the Slooh telescopes. So you don't need this massive telescope because you're getting one as part of that deal. So
exactly.
It's a cool little thing, and I think a lot of people that actually had it in the last promo, I have heard from a few of them, and they are having fun with it. Yeah,
one thing too, guys, we're doing a special perk. You can get on this broadcast for a total solar eclipse. Bob's going to be on site in, I guess it's Cairns. Is that New Zealand or Australia?
Australia.
Cairns, Australia. He'll be on site live. We'll be on, and you can join the broadcast with us for a while. And I can guarantee you that's going to reach, I'm saying millions, because that's typical for something that big. So it's a huge event, and if you've got a book, if you've got something you want to promote, hey, I'll let you do that. To this worldwide audience that's coming out. So it's please consider it. It's a great perk. There's only 10 slots for that. So, again, it's another unique thing that we're not going to offer post that event. Guys, we got about 5 more minutes in before we got to get off. We are going to keep running live images on the Slooh.com homepage for another 45 minutes or so. Also, this panel will replay automatically, so if you want to come back later, you can always listen to it or watch it again if you'd like. I want to thank Bob Berman from Astronomy Magazine for joining us, and a longtime Slooh editor. He's been with us for, I don't know, 5-6 years at least, and he's been a part of the beginning of Slooh. We are celebrating our 10-year anniversary.
Didn't you hear your brother Pat? Did you hear your brother Pat? He said I was there before it even opened in 2003.
I know. I was going to say, it's right. I didn't know that. I didn't know. I forgot. You were actually
10 years.
You were in the beginning. You were in the beginning stages. Bob's been with us a long time, and hey, Bob's an authority out there, and we always love having him on because he knows a lot about space, but he also knows how to talk about it. I mean, he gives it to he kind of simplifies it for all of us, me included, to make us understand. So we always love having Bob on. I want to thank Mike Paolucci, the founder, coming on. Mike started this thing 10 years ago, and he had some really emotional stories about how he came out of the ashes of 9/11, and to Blake Wallens, who passed away in that event. And I also want to thank Paul Cox, civil engineer, who's controlling the scopes tonight live from the Canary Islands, but he's doing it from the UK robotically. So it's a pretty amazing thing. And you guys, any last thoughts before we get off? We got a lot of chatters asking questions about this, and people, of course, want to know the damage that this thing would cause if it hit us. And maybe, Bob, you could really quickly tell us, this particular asteroid is moving very fast. It's not gigantic.
We're seeing it. Yeah, we're still. Paul is still showing us live images. We're seeing it change. There it is, as it's speeding past Earth. We're seeing it live right now. And what would it do if it actually hit us? If it were, instead of being 7 times the distance to the moon, if it was a direct hit? Unfortunately, an object of with this possible mass, you're talking about as much as perhaps 60,000 tons, would come in at full cosmic velocity, could easily destroy a city, even though you'd think, well, 14 stories, that's not even a city block. But the damage it does is far greater than what the mere size of it is, because the speed is more important than the mass. This is not the kind of object that would end life on Earth. It is not the kind of object that would change life greatly on Earth, like that 165 million years ago, which is why we're here. Pat and Paul both consider themselves mammals, as do I. And the reason we mammals are here talking to you is because mammals gain the upper hand thanks to that last impact. That's what destroyed our enemies, the bad guys, the raptors, the dinosaurs, the amphibians, and let us little sneaky rodents and other mammals emerge and multiply, pave the way for rats and sitcoms and everything that we see around us today. So we're here because of an asteroid.
Wow, that is fascinating stuff. All right, Paul, well, we're going to have to get off. Again, this show will keep replaying in the Hangout box. If you missed any of it, you can start it from scratch. So feel free to watch the live imagery up until about 5:30 Pacific. Paul Cox is going to come back on live very shortly. So, what, 0200, what time is that locally? That's like 7 p.m.?
Yeah, it's another 2 hours time, I believe.
Yeah, 7 p.m. Pacific, 10 o'clock Eastern. Come back to Slooh. Paul will be giving a recap of the asteroid, showing both live as well as animations. So you should join him for that. And then tomorrow, a comet show. There's a comet that came in that's actually a lot brighter than anyone expected, and we're going to follow that one as well. So that's a comet. Those things are pretty cool, too. You'll get another taste of something flying around the solar system. You know, Bob, if you're around, you're always welcome to join us. That one's at 7 o'clock your time, I believe. Right, Paul?
Yes, and don't forget that's part of our month-long campaign of live astronomy every single night up until the 10th of October, and that's all in support of the M.P.E.C campaign.
Exactly.
Okay, very good, very good.
All right, guys. Well, I appreciate it again. Again, support Slooh. We're doing great things.
Yes,
we want to do more of these shows, and we want keep you guys educated on what's going on out there and show you live what's happening. We can do it. We have the technology. But, of course, we need your support in order to do that stuff. So consider membership or one of our perks in the M.P.E.C campaign, slooh.com/M.P.E.C. For Slooh Space Camera, this is Patrick Paolucci for Bob Berman from Astronomy Magazine and Paul Cox, Slooh Engineer, who's got the nice placard that I can't get working on mine. I like that, Paul. You gotta tell me this whole Coxy thing. This is the Coxy. I like that nickname, the Coxy. All right, guys. I'll talk to you later. All right. Take care.
Good night.
Good night, everybody.
Good night. Okay, I'm just getting this out. All right, guys, you ready to roll?
What time is closest approach exactly?
5 this morning. It's on that document. I think it's 13 minutes past 5.
Okay.
That's universal?
Yep.
All right, guys. We're starting to broadcast live now, so I'll start us up. Hi, everyone. This is Patrick Paolucci with Slooh Space Camera. I'm here today with Bob Berman, longtime Slooh editor, friend, and Astronomy Magazine columnist, as well as with Slooh engineer Paul Cox. And tonight we have a special show plan for you. We are going to be tracking live the potentially hazardous asteroid 2012 QG42, which is on its close approach today. And we're going to be showing this live from the Canary Islands. Paul Cox, our engineer, is going to be tracking this using our own telescope equipment in the Canary Islands. We have multiple telescopes that are going to be looking at this. For those of you remember, we've been this is the second asteroid that has come in on a close approach to Earth that is not expected. The last one happened in June of this year that we tracked as well. And we're excited to do this as well to show you guys and to educate the public of what's going on out there flying around outer space and some of the dangers that pose to Earth. Now, before we get started, I wanted to mention a couple things regarding...
Click the button at the bottom.
Is it on?
No, I'm still seeing you.
Okay. I don't know why.
If the window has to be active, Pat, when you're screen sharing an image in Windows, you've got to actually be on the image. Otherwise, it won't show up, I think. That's what I had yesterday.
Is that showing now?
Yes, it is, yep.
Okay.
And there's Bob.
Is that the main screen? All right. So, Bob, we're live right now, buddy, just so you know.
Okay.
We'll just do a little cone of silence for a second, and then I'll start it up. Just got to double check a few things. Yeah. All right. I'm going to put this over now. Oop. That's not what I want. Alright. It should be yes. Probably, I can hear you can hear some breathing going in. Okay, you guys should see us. You go to the home page. You should see everything, right? Alright.
Yep, it's showing fine here, Pat. I'm going to mute again. Bye.
Okay, bye. So often, images of the asteroid for you for those who are watching this on YouTube only or on the G+ page of Slooh. But if you go to the slooh.com homepage, that's slooh.com, you can actually control these feeds that we're showing, as well as other graphics that Paul's incorporated in other images. So that's the best spot. In addition to that, you can also access the Slooh conversation box, which can ask questions to Bob, myself, or what have you. And so we recommend you go there for the best presentation. But Paul, perhaps you can quickly give us a review of the channels that you've got us set up on tonight.
Yeah, certainly. I would make the personal recommendation that people don't watch on the YouTube live channel or don't watch just the Hangout. Watch it on the Slooh homepage where the Hangout is embedded, so you'll still get to see the Hangout. But if you go to the homepage, it gives you the opportunity of controlling which telescope feed you're going to look at. And we've got two live feeds set up tonight. The first one, if you look at our homepage, there's a big circle there, and inside that is the live image. So if we go on the first feed that we've got set up tonight, it's the half-meter telescope. Now, although this is a massive telescope and our best telescope, it's actually not the best instrument to be looking at this object, because if you go to that image on the screen, I'll tell you where the asteroid is. It's a little dashed line at about the 9 o'clock position, off to one side. Now, as color images come in, that little dotted line, it might come up red, green, and blue because we take different images through different color filters. But it will give you a very good view of the asteroid moving across that star field every few minutes. Now, the next feed we've got up is probably the best one that we've got tonight. This is what we call our T2 high mag telescope. So this is
starting Slooh. This is actually our 10th anniversary, believe it or not, coming in December of this year. And Bob, you've been with us for multiple years, as long with Paul as well. And maybe it's kind of fitting that I guess the end of the world is planned for December. That's going to be our official 10-year anniversary of Slooh. So it's kind of funny there. But so Bob, tell us a little bit about this particular asteroid and your thoughts on this. I'm sure this is kind of scaring me a teeny bit, because this is the second unexpected asteroid that's paid a close visit to Earth in the past 60 days. And on top of that, we just had another comet or asteroid slam into Jupiter just a couple days ago, and that was not expected either. So can you tell us what your thoughts are on that while we start this broadcast?
Well, it really is worlds in collision out there. It's, you know, we used to call it space, which suggests there's a lot of room, empty room up there, but we know that there's a lot of other things keeping us company, close company, and sooner or later we're going to have something with our name on it that comes in. It wasn't that long ago. There are people alive today, not a lot, but there are some people alive today who were alive when the last truly big object came in, blew up in the atmosphere a few miles up, and destroyed everything within 50 miles in all directions. And that was just barely a century ago. So can it happen? Absolutely. Will it happen? Absolutely. It's only a question of when. And these objects should remind us of that.
So, Paul, are you? Hopefully, you can hear me. We're looking at several feeds now on the Slooh.com homepage, and you guys, that's the best spot to look at this. I will, or Paul will, be screen sharing it every. Okay. Bob, I can hear you breathing.
How's this? Better?
Yeah, that's good. Let me see. Have we flicked over yet? I'm still looking.
Minute and a half.
Okay. I gotta tweet out, man. I haven't done this. We might start a little bit late here. It's okay. Let me just do this really quick. .30, isn't that?